so yesterday we had some homework questions. We were told to go online and check out what translation is actually about, as well as rotation. Yesterday in class we finished our reflection. So we reflect along the mirror, along the line, in this case line AB. And then we use the prime, one dash on the top right hand corner, as though it is a power 1, but it is not. It's a prime, okay, to indicate that it is a reflected point, an image. So in this case, a translation is just moving a figure in a certain direction. So it's just moving from one side to another side, from one position to another position. Now when you move in the classroom, a person moving, the shape and the size doesn't change. Okay, maybe that's not a very good example. If I were to move my set of notes from the table over here, I move it to Sean's table. The shape and size didn't change. It is a translation, just a movement only. Okay, there is no rotation involved, there is no reflection involved. It is just moving from one point to another point. Then they introduce you something called a vector, which you don't have to be concerned about. It just basically tells you how it is moving. Okay, so I'll skip this portion. All you need to know is how many units to the right, how many units upwards, or how many units to the left, how many units downwards. Okay, because we have our vertical axis, we have our horizontal axis. Likewise, our movement can be described on the vertical and horizontal axis by describing how many units to the left, right, up, down. Okay? So in this particular case, the point L is translated according to this particular vector. This vector has an arrow. It shows us 3 units to the right and 1 unit downwards. 3 to the right, 1 down. So for example, this point L, 3 units to the right, 1 down. So this we call it L prime. Likewise for this K over here, at the right angle, 3 units to the right, 1 unit down. The final point M, 3 units to the right, 1 down. And here we have our translated image. Essentially, this triangle is moved. The whole triangle, 3 units to the right, 1 unit down, in accordance with this particular vector. Okay? So there are different vectors, of course, that we can translate by. For example, over here, if we are moving 1, 2, 3, 4 units to the right, 2 units up, and then we can use the same original triangle. Let's start with point L, 4 units to the right, 1, 2, 3, 4, and 2 units up, and we get L double prime. Double prime indicating that this is another different transformation. Okay, it is different from our L prime, and so on and so forth. That is translation. Okay. And because they are every single point is moved in the same direction, with the same magnitude, the shape and the size doesn't change. So they remain congruent. Now the next one, rotation. Quite intuitive. You have to rotate about a pivot, right? About a fixed point. So in this case, they gave an example. O is our fixed point. So in this example, rotation center O and anti-clockwise. It is translated to image blah blah blah. Okay, let's see what else. Okay, so in this particular example, it is 180 degrees anti-clockwise about O. So if we were to draw a line, if I'm trying to transform this point M, I want to rotate it 180 degrees anti-clockwise. By the way, 180 degrees anti-clockwise, 180 degrees clockwise, no difference, right? So no difference in this case, but if it is like 70 degrees clockwise versus 70 degrees anti-clockwise, now there is a difference. Okay, so you draw a line already, then this is the pivot, this is the point that doesn't move. So we're going to move this point 180 degrees. Did I say anti-clockwise? Okay, anti-clockwise. So the other way around, anti-clockwise. Okay, I can't really draw the perfect semicircle. So anti-clockwise 180 degrees, and you will end up at this point. So every single point, you do the same thing. I will change another color. For example, point K. Okay, so with this being our radius, we draw another semicircle. over here. Okay, this is a very bad example. Try again. Okay, you get the idea. 180 degrees, keeping the radius the same. And then you will get your reflected image. And in the same way, the triangle remains, the size of the triangle remains, the shape also remains. So they are also congruent. So these three blanks, a figure is congruent to its image after reflection, congruent after translation, congruent after rotation. Okay, so now back to the empty set of notes. Determine whether the figure A, B, C, D is congruent to A prime, B prime, C prime, D prime. Okay, so also if it is yes, if they are congruent, then state the transformation. Okay, so yes, they have the same shape and the same size. So yes, translation. Okay, translation, how many units? 1, 2, 3, 4, 5. 5 units to the right. So the next one, are they congruent? No, they are not congruent. How do you know that they are not congruent? There is something that is different. So what is different? Remember, it's just same shape, same size. Huh? So first, do they have the same shape? We can call both of them a parallelogram, right? But are they the same size? No. So not congruent. Different size. Okay, part C. Are they congruent? Same shape, same size? Yes. Yes. What is the transformation over here? Is it a mirror image? No. Is it a translation? No, then it has to be the other one, right? What is that called? Rotation. Rotation. Okay. And the final one. What is this? Do they have the same shape? Same size? Is it a translation? That means moving how many units to the left, right, up, down? No, right? How about rotation? Is it rotation? Then what is it? Reflection. Okay. Reflection, I think it is along this line. Just my estimation only. I think it's somewhere. So basically, if you really want to find out where the line of reflection is, you join up these 2 points, you find the midpoint. Then you join up another 2 points, you find the midpoint, then you join the 2 midpoints. That will be your line of reflection. Okay? So this over here is a reflection. Yes. Okay, now we come to the more typical type of questions for our congruency type of questions. Okay, so in the figure below, A, B, C, D, B, E are congruent. So just a quick recap. Note that the first term, the first letter and the first letter, they are corresponding. So the A and the D are corresponding. The B and the B are corresponding. Okay, no surprises over there. B and B. And then finally we have our letter C and letter E. They are corresponding. So if I want to find the angle Y, I look in the diagram. Okay, Y will be my BE. Angle. I want to find part A, the length of X. X will be our BE. Then I check back to the question. BE, does it apply? Does it appear anywhere? Oh yes, it is over here. BE is found here. Then I look for the corresponding side. Corresponding must be BC. Then I go back to my diagram and see whether BC is given to me. Oh yes, it is given to me. So simple. Okay, quite straightforward in this particular case. X will be equal to BC, and we state further that it is 9.3 cm. Okay, then now the next one, Y. Can you please do it yourself now? Just about 30 seconds. I think you should be able to do it. Okay, what is your value for y? We think, what do you have for the value of y? 8.5 cm. Okay, so you state that that is DE, right? DE, so 8.5 cm. Okay, now the last one, Z. What is the angle Z? So try it now, about 30 seconds again. Arisha also not here. Okay, who needs more time? Anybody? Akira, can you help us with this question? What is the corresponding angle? Okay, angle Z will be equal to angle CAB. Okay, absolutely correct. So angle Z is our, for example, BDE. BDE. CAB, CABE, CABE, DB. Okay, she saw it as EDB, right? Can, no problem. EDB corresponding to CAB, correct. And we want to find this angle now, but we don't know the value. So what do you do? Okay, 180 minus 64 minus 35. Do you remember to write the reason? Angle sum of last one already. Did you say something? Triangle, yes. Angle sum of triangle. Okay, so calculate this and you get minus, what is this? Minus 99, 81 degrees, yes. So that's it. Okay, now in a figure, lines AE and BD bisect each other at point C. What does bisect mean? Bisect means cut into two equal parts. Okay, so by AE and BD bisect each other at point C. So that tells us that these two lengths are also the same. Can you indicate that? Then they also tell us that AB is parallel to ED. So name a pair of congruent triangles. What do you think is a pair of congruent triangles? You try it out by yourself. I'm very particular about the naming of your triangle. There will be different answers from different students. Okay, because for the same triangle ABC, somebody might call it ABC, somebody might call it BAC, BCA, CAB, CBA, so on and so forth. Okay, so there are many ways. What is important is that regardless of how you name a triangle, the corresponding congruent triangle, the naming is also the same. Okay, so this is my answer. I'll just stick with triangle A, B, C, and then you write congruent. Congruent 2. Okay, now we need to fill in the name of the second triangle. So I started off with A. So I search for my point A, this point. It is definitely going to be corresponding to either points E or point D. So how do we decide? You have to observe. I observed that point A is connected to point C by this one dash. Okay. At the same time, my point A has a side that is also parallel. Okay, so we see that by the way it is drawn, my point A should be corresponding to my point E. Can you see that? Okay, so this is corresponding to point E. Now that this is done, the next point that I took was B. So AB was on that parallel line. So my next point will be D, followed by C. Okay, then let's do some checks. Let's do some checks. What information do we know? BC. Okay, BC. If it is congruent, then it should be the same length as DC. And it is true. BC, DC, same length. Okay. What else do we know? AC, the length of AC, also the same as the length of EC. Same. I don't know the length of AB and DE, so I cannot talk about the length. So far, I currently have 2 lengths only. But do I know more information? How about the shape? When we talk about shape, we are talking about angles. Are there angles over here that are the same? Turns out there are. There are quite a number of angles that are the same. So one pair of angles that are the same will be this pair over here in blue. What are they called? Do you remember? Starts with V. Vertically opposite angles, right? Okay, let's double check. B, for example, angle BCA. Angle BCA. Okay, let's check on the other side. BCA. DCE. Supposed to be equal. So let's check. DCE. Yes, correct. Vertically opposite angles. What else is there? We also have our alternate angles. The letter Z. And then another pair of alternate angles. So all these you can test them out to check out which is corresponding to which. Okay. Actually, looks like it was actually easier to identify the congruent triangles, the naming of the congruent triangles by the angles. Because the angles themselves, they are already pegged to a point. So actually based on these properties of the angles in parallel lines as well as vertically opposite angles, I could have concluded straight away that A corresponds to E, B corresponds to D, and C corresponds to C. Okay, then we didn't exactly need to talk about all the different lengths already. So in practice 2, please try it yourself now. How much? 120. Is it? Okay, correct. And then let's just go down the row. Matthias, value of y equals to which angle? I cannot hear. Oh, sorry, cm. So y is equal to ts. Okay, and the value? Ts, 4.5 cm. Good. Okay, next, down the row, who do we have? I haven't finished C, okay. You want to skip? You want to skip? You allow him to skip? Don't allow. Daniel, she don't allow you to skip. Okay, so y is equals to 4.5 cm. Let's replace that. This will be 4.5 cm. We want to find EA. Question mark over here. Looks like we need one more length, right? Because they gave us the perimeter. Our perimeter is 24 cm. So all this will be 24 cm. To find EA, I need another length, BC. Daniel, maybe you can start by telling us what BC is. RS equals to BC. Sure? RS. Daniel, look at the screen, huh? Okay, so first, do you agree that this is 4.5 cm already? Okay, and the yellow color highlighted parts will be 24 cm, right? Then we want to find the value of EA. Okay, so now BC equals to RQ. This part is the same as RQ, which is how much? 3.5 cm. So now we can find the value of EA. EA 24 minus 4.5 minus 5 minus 3.5 minus 4 cm. Okay, so you can figure this out by yourself. Next question. Practice 3. Okay, please try it.